Hello everyone, this lesson is about derivatives of transcendental functions. So, as I've mentioned previously in our synchronous class, um, transcendental functions are exponential, logarithmic, trigonometric. Then we also have here inverse trigonometric. And then we have hyperbolic. And we have inverse hyperbolic. Okay, so let's start with exponential functions. So again, we have here the objectives. It should be for you to be familiar with the properties of exponential, logarithmic, and trigonometric functions, which I know everyone is familiar with because you discussed this exponential and logarithmic functions in Math 165 and trigonometric in Math 166. Then you should know how to differentiate the different forms given the functions explicitly and implicitly, or defined implicitly or explicitly. And then we could be able to determine also the higher order derivatives of exponential and logarithmic functions and trigonometric functions later. Alright, so we start first with the laws of exponents. So these are the laws that we've discussed also in algebra. So that if we have a to the n, that means you multiply a by itself. You multiply a by itself n times. Alright, and then a to the m raised times a to the n is a to the m plus n. Which means that if you have two different functions with the same base, to multiply, we simply add the exponent. And if it's division, we subtract the exponent. If you have a to the m times a to the n, the product is a to the m times n. And then if you have ab raised to the n, you can raise both to the n. Same thing happens if it's division. Okay, actually, this should be a over b to the n. Dapat nauna ito dito. You should have this be here, right? Then number raised to 0 is 1. Okay, and this one, a to the m over n, can be written as a to the 1 over m, n raised to the m. And this is on logarithms. I mean, again, if y is a to the log of x, that is x. We discussed this last time. I'm going to discuss this again when we go to derivatives. Alright, so the next is on the derivatives of exponential function. Okay, you either have the base equal to a or the base is e. So if you recall, we discussed that when we discussed logarithms, you could have natural logarithms and common logarithms. For natural, you have the base is e. But there are times when the base is not e, but any real number. So here, we have the derivative of a to the u is equal to a to the u ln of a times the derivative of u with respect to x, where u is a function in terms of x. And then a here is any real number. Okay, now there are times when the base a is not, or the base a is equal to, hold on, let's see what it says. The base a is e, and when the base is e, the derivative is e to the u du dx. Again, u is a function in terms of x, and this e here is actually equal to 2.71. So it's a constant number equal to 2.71. Okay, so look at this given exercises here. We're given y is 3 to the x minus 3 to the x. How do we solve for the derivative? So we have it's 3 e to the x minus 3 to the x. So how do we find the derivative here? Now look, as I mentioned, for you to find the derivative, when you are differentiating functions, you have to write which formula to use. So pwede naman itong isulat as the derivative of a to the x is equal to a to the x ln of a. But this is when you have x. Pero actually what we use here is that what is the derivative of a to the u? It's equal to what? A to the u ln of a du dx. But in here, our exponent is simply x. So the derivative of x is actually 1. Kaya actually we have here 1, which represents the derivative of u with respect to x. Ln of a times the derivative of u with respect to x. We have here u, which is what? X. Alright, so for this one, what's the derivative? What's our y prime? Diba, if we have a constant times another function, we simply write the constant term and then we multiply it by the derivative of e to the x. And what's the derivative of e to the x? Kasi we have what? The derivative, let's write it down here. The derivative of e to the x is e to, kasi diba we follow this formula here. Hold on. Let's rewrite this first. Let's write first, before this one, let's write the derivative of a to the u is equal to what? A to the u ln of a times du dx. So that if you have the derivative of a to the x, that's a to the x ln of a times 1. That's why it's just simply is a to the x ln of a. That's how you get this one. Now, for us to find the derivative of e to the u, okay, let's put it down here. Hold on. This time, the next is, hold on. The next is, okay, how do we find, what is our formula for the derivative of e to the u? That gives us what? E to the u du dx. Okay, so it's here. Diba, we have two formulas here that we discussed. The derivative of e to the u is e to the u du dx. The derivative of a to the u is a to the u ln of a du dx. Right? So, next is, we're asked to find the derivative of this one. So again, we say that we copy the constant first, that's 3. Then we multiply it by the derivative of e to the x. And what's the formula? E to the u du dx. So our u here is x. So the derivative is e to the x times the derivative of x, which is 1. Minus, what's 3 to the x? It actually follows a to the x. So what's the derivative of a? What's the derivative of a to the x? So here, what is our a? Okay, let me write it down. This is your a. So we have to use a to the x. So the derivative is what? 3 to the x. The derivative is 3 to the x ln of a. What is our a? 3 times the derivative of x, which is 1. Okay? But we may not write 1 anymore. Kaya lang, to make it, so that you know that the pattern is that we use a to the u ln of a du dx. Alright, so if you simplify, we get y prime is 3 to the 3 times e to the x minus what? 3 to the x ln of 3. Alright, can we factor 3? Is 3 common? It's not. Because here 3 has a power which is x. So it's not the same as 3. So we don't have any common factor here. That's the derivative of 3 to the x minus 3 to the 3 e to the x minus 3 to the x. Okay, let's have the next problem. The next is this one. You have e to the x squared plus 1. So again, how do you what formula will you use? Is the derivative of e to the u. E to the u du dx. So here, this is u. So what's y prime? This is u. So what is y prime? It's e to the u, e to the x squared plus 1 times the derivative of x squared plus 1, which is 2x. So this can actually be your answer already, but we could write it also this way. Y prime is 2x times e to the x squared plus 1. Okay, let's have the next one. So for the next one, we have here t. So it's f of t. So the variables on the right side should be t. Alright, so f of t, what's the derivative of f of t? Okay, what's the derivative of t? It's 1. Now for this one, you have to use here derivative of product, because you have the product of 4t and 4 to the t and 3 to the t. So how do we also have to use here derivative of what? U times v, which is u dv plus v du. So here, this is your what? This is your u, this is your v. So we copy u, that's 4 to the t. Then we multiply it by the derivative of v. What's the derivative of 3 to the t? We use a to the x or a to the u. Okay, so the derivative is what? 3 to the t ln of 3 times 1, or simply 3 to the t ln of 3. Again, by the way, in 3 to the t, this is your a. Hold on. In 3 to the t, this is your a. And this is the variable that you use. So, a to the t, the derivative is a to the t ln of a, ln of 3. Then plus, hold on. Plus, we copy 3 to the t. Let me write it down here. 3 to the t times the derivative of 4 to the t. So again, in 4, note that, let's put here note. Note that in 4 to the t, this is your a, and you have here the variable t. So the derivative is now what? A to the x, so 4 to the t, ln of what? 4. Okay? So, what is now the next step? So, can we group, or do we have similar terms here? Or do we have a common factor? Kasi there is no common factor kasi may 1 ka dito. So, it's actually 1 plus what? 4 to the t. We can factor out of these two. Out of this and this one, meron tayong common factor. And that is what? 4 to the, hold on. It's 4 to the t, 3 to the t. Then this is out already, so what's left is ln of 3. And here, this already out, plus ln of 4. So we'll have here 1 plus 4 to the t, 3 to the t, times, this actually ln of, you have the sum, so it's actually ln of 3 times 4. So if you simplify further, you'll have, pwede namang mauna tong 4 to the t, 3 to the t, times ln of 12. Because ln of 3 times 4 can be written as ln of 3 plus ln of 4 by the laws of logarithm. But you have here plus 1. Okay, questions for number 3. I'm sorry. I forgot I'm doing a screen recording. Okay, let's go over this one. Okay, we're given GW is W squared minus 3W plus 1 times E to the W squared. So, here, what formula do we use here? What formula do we use? We'll use here derivative of what? You have the product of this and this one. So, first, we'll have to use here, the first formula that we have to use here is the derivative of the product, U times V. So, it's U dV plus V du. Okay, what's our U here? So, which what is g prime of w? U, what is your u? W squared minus 3w plus 1. So remember, our variable here is w. So, what's the next formula? Derivative of what? E to the u. Because you have here e to the w squared. And what's the derivative of e to the u? E to the u du dx. So we copy e to the w squared times what? E to the u times what? 2w. Plus, we copy e to the w squared times the derivative of w squared minus 3w plus 1, which is 2w minus 3. Okay? Let's just, hold on. What happened? Hold on a second. Okay. Let me put this. Okay, so let me write this formula a little bit higher para makasulat ako dito sa kabilang side. Alright, so we have here to use the derivative of hindi makita. Okay, derivative of u times v is u dv plus v du. Then we solve for, we use the derivative of e to the u, which is e to the u du dx. So we use these two formulas here. Okay, so let's continue this para diretso siya. So we have plus, okay, so u dv plus v, which is what? E to the w square times the derivative of u, which is 2w minus 3. Okay, now the next step is to check if we have a common factor. So in here we have, this is our first term, this is the second term. So what is common between the first and the second term? E to the w square is common, right? Ito. This is here on the first term and is also in the second term. So we factor out e to the w square. So what's left inside is 2w times w square minus 3w plus 1 plus 2w minus 3. Then if we simplify further, this gives you e to the w square multiplied by what? We need to distribute this time 2w. So we get 2w cubed minus 6w square plus 2w. Then plus 2w minus 3. So if we simplify further, we group similar terms. Now take note that this and this are the same. So we have e to the w square times 2w cubed minus 6w square plus 4w minus 3. So that gives you your g prime of w. Okay. Now the next is, sorry, we don't solve for this yet, because this is second derivative. Because it's here. This is the question. Yeah, you don't solve for the second derivative. Okay, so we have, hold on. Okay, so we'll just have to solve for this one, not the second derivative. Is it number 5? Is it number 5 here? 2 over. Let me check. It's 2 over. Yeah, okay. So let's do this. We have, for number 5, we have this one. Again, what is your y prime? So we have to use here what? Ito, this is the first part. Because you have here constant. Take note, this is what? A constant over this denominator. So we have to use this one. That's the first formula. So we have in the you have what's the derivative of the constant over? We have negative. Pwede namang you could write this as what? Because we're used to writing this as negative k times the derivative of v over v square, right? Okay, so negative k. So you have negative 2 times the derivative of the denominator because you have dv. So what's the derivative of e to the x? So you'll use this one. You'll use d of e to the u. Derivative of e to the u is e to the u du dx. So what's the derivative of e to the x? It's e to the u times the derivative of x, which is 1, minus e to the negative x times the derivative of negative x is negative 1. Alright, over e to the x minus e to the minus x is squared. Now, it says here that we'll also be using this one. Now, we'll be using this one. So, if we have to solve for the second derivative. So, in the meantime, we don't use this. I mean, we are not using this one. Okay, so I'll just delete this later. Okay. Alright, so again, we use this formula. We use this one. Hold on. Okay, so we'll be using this formula. Alright, so we have again negative 2 in the numerator, the derivative of the denominator, which is e to the x minus e to the minus x times negative 1, divided by v square, and that's this v square here. Alright, so we use this one to solve for the derivative of e to the x, e to the u du dx. Then we simplify. So what's the resulting y prime? We have negative 2 times what? E to the x plus e to the minus x over e to the x minus e to the minus x is squared. Okay. So again, can we cancel? Pwede ba? We could not. We can't cancel e to the x plus e to the minus x because in the denominator you have minus. So how do we simplify this? Let's get rid of the negative exponent. So we have negative 2 times what? You have e to the x plus 1 over e to the x. In the denominator, you have e to the x minus 1 over e to the x. And we square this. So, let's just continue it here. So, therefore, to simplify, this is the same kasi. It's 2 over, right? Okay, so, for this one, we get simplify the numerator first. So how do we simplify the numerator? What do? We need to what? Find the LCD for the numerator. So what's our LCD? In the numerator, the LCD is which one? You have minus 2 times the LCD is what? E to the x. Our LCD is e to the x. So, we'll have what? In the numerator. It's like, di ba yung nagko-cross multiply? So, you have this one, e to the x, and this one. So, it gives you e to the x plus x. So, it's e to the 2x minus what? Minus 1. Right? Then, in the denominator, we also have to find the least common. So, what's our LCD here? So, our LCD is also e to the x. Then, hold on. This should be plus. This should be plus, right? This should be e to the 2x plus. Alright, that's our LCD in the numerator. e to the x plus. Now, in the denominator, we also have e to the x. So, in the numerator, we're simplifying this one. So, we'll have e to the 2x minus 1. And this is a square. So, if we continue simplifying, then what happened with the numerator? Negative 2 times what? Times e to the 2x plus 1. Sorry. Yeah, it's e to the 2x plus 1 should be here, right? E to the 2x plus 1 over e to the x. Okay? And then, we multiply this by the reciprocal of the denominator. So, what's the reciprocal of the denominator? Actually, let's simplify this here. Because this is the same as what? You have e to the 2x minus 1 is squared. Okay, hold on. Let's rewrite the entire thing. So, we have e to the 2x minus 1 over e to the x is squared, right? So, this gives you e to the 2x minus 1 squared over e to the x is squared. And when simplified, this is e to the 2x minus 1 squared over what? E to the 2x. So, we multiplied this numerator by the reciprocal of this one. So, what's the reciprocal? It's actually e to the 2x over e to the 2x minus 1 is squared. Okay, so if we simplify further, what will happen? You can what? You can cancel one of the, because this actually is what? This e to the 2x is actually what? E to the x times e to the x. So, since this is, let's write it down here, not here. Since this is equal to e to the x times e to the x, we can cancel this with this one. So, what's left in the numerator? We'll now have negative 2 times e to the 2x plus 1 times e to the x. One of the e to the x is left. In the denominator, you have e to the 2x minus 1 is squared. So, that gives you the final answer. Okay? Okay, there are other examples here. So, let's do these exercises. The first one is x squared e to the 2x. So, how will you solve for the derivative of this one? What do we do? Again, what's the first formula that we use here? We have to have this be your u and this as v. So, what's the derivative of, hold on a second. What's the derivative of u times v? We use here again the formula for the derivative of product. So, you have u dv plus v du. Okay? So, what is our y prime? We copy u, which is x squared, times the derivative of v. Now, what is the derivative? What's the derivative of e to the 2x? We use the derivative of e to the u, which is what? E to the u du dx. Alright, so here in e to the 2x, this is your u. So, what is the derivative of e to the 2x? That will give you e to the 2x e to the u times the derivative of u, which is 2. E to the u du dx. Your u is 2x. Then plus, we copy e to the 2x because we have u dv plus v. So, we copy v times the derivative of u, which is 2x. Then, we factor out the common factor. So, what's common? E to the 2x is common and 2 is also common. So, the result will give us, if we factor out 2e to the 2x, now, This is out in the first term. Nandito na siya. So what's left inside is x squared. Then, e to the 2x and 2 is out. Right? So, x is left. Also, it means x is also common. We should have factored it out also. So, dapat we factor out 2x. But anyway, this is what I'm telling you. Say you did not see that x is also a common factor, then we can continue factoring. So, we have here 2x. We factor out x. So, we'll have here x plus 1. Okay, so that's your y prime. So, look, if say from here, this is another solution. If say we were able to see that what is common is 2x e to the 2x. Alright, so 2x is out already in the first term and 2x. So x is left. And then in the second term, you have e to the 2x and 2x. So 1 is left. So you get the same answer. 2x e to the 2x times x plus 1. Okay? Now, let's go over the next one. Oh, there's no solution. There's no... anyway. Okay, the question here actually is determine the derivative and simplify. Okay, let me solve the next number also. So let's just do it here. So we are given g of x. Let's rewrite it. Hold on a second, huh? So I'll see that. I'll get it from my laptop because it's hard going back and forth. So we have okay. So let's solve the next one, which is, let's do it here. Do we still have a space? Yes, we have. Let's do number 2. Right, for number 2, we are given g of x is 2 e to the x squared minus 2. Sorry. X 2e to the x squared minus 2. And then minus 7 to the x squared minus 2. So the exponents are both x squared minus 2. Okay, so what formula will you use here? Derivative of sum and difference. But for the first one, how do we find g prime of x? So, diba, if we have a constant times a function, we simply what? We simply copy the constant term, and then we multiply it by the derivative of e to the x squared minus 2. So, what formula will you use here? Let's put here, use. Okay, so for this one, which formula do we use? It's the derivative of what? E to the u, which is what? E to the u du dx. Alright, so we have e to the what? What's the derivative of e to the x squared minus 2? This is your u. So the derivative is e to the x squared minus 2 times the derivative of u, which is what? 2x. Then minus, we use which one? And the derivative of what? A to the u. Because remember, this is a. Hold on, let's use a different color. This is a, and this is u. So what's the derivative of a to the u? It's what? A to the u, ln of a, times du dx. Alright, so what's the derivative of 7 to the x squared? We have what? A to the u, so 7 to the x squared minus 2, ln of a, times the derivative of u. and that is what? 2x. Alright, so again, the next is to find if there is a common factor. Do we have any common? Yes, 2x is common. Kasi we have here 2x, and we also have here 2x. So we factor out 2x. So what's left inside? You have 2 e to the x squared minus 2. Then minus 7 to the x squared minus 2 times ln of 7. We could not simplify anymore. There's no common, there's no similar terms. Alright, so that's number 2. Let's do number 3. So for 3, we still have a space, yeah. We have h of t is equal to t squared minus 6t plus 3 times e to the t. Alright, so again, what formula will you use here? We use derivative of what? Ano mo ng formula dito? We use what? First, we use the derivative of product. We have u times v because this is your u and this is your v. So what's the derivative of u times v? u dv plus v du. Okay? So for this one, h prime of t is, we copy u. That's t squared minus 6t plus 3 times the derivative of e to the t. So again, anong gagawin dito? What's the derivative of e to the t? E to the u du dx. Right? So we use here again which one? Derivative of e to the u, which is e to the u du dx. So what's the derivative? E to the t times the derivative of t, which is 1. Okay, plus e to the t times the derivative of u, v du. We have derivative of u. Your u is this one. So it's 2t minus 6. Alright, and then again, do we have a common factor? Yes, e to the t is common. So what's left inside? T squared minus 6t plus 3 plus 2t minus 6. Okay, so we have here similar terms. What's similar? You have 6t and 2t. So therefore, this is now e to the t times what? T squared minus 6 plus 2 is 4t minus 6 minus 3. Minus 6 plus 3 is minus 3. Sorry. Again, 6 minus 3. 6 minus 3 is 3. Negative 6 plus 3 is negative 3. So this is the simplified form. Okay, so that's number 3. Let's do number 4. Let's do number 4 on this side. So for number 4, we're given u of v is equal to what? 4 minus e to the v over what? 1 plus e to the negative v. So here, your variable is v and the function is u. The name of the function is u. So how do we solve for the derivative? You have u prime of v. Or sometimes you could write this as what? The derivative of u with respect to v. And so we use here what? Derivative of what? What formula do we use here? So we'll be using here, we have to use here the derivative of what? U over v, quotient. So you have here v du minus u dv over v squared. So here, this is our u and this is v. So what's the derivative? We have v. What is again your v? 1 plus e to the negative v times the derivative of 4 minus e to the v. So it's 0 minus, what's the derivative of e to the u? It's e to the v times 1. Again, we have the derivative of e to the u is e to the u du dx. Alright, then v du, then minus what? Minus u. What's your u? It's 4 minus e to the v times the derivative of the denominator. Derivative of v. Again, we have v du minus u times the derivative of v. It's 0 plus what? E to the negative v times the derivative of negative v, which is negative 1, over 1 plus e to the negative v squared. So when we simplify, we get the derivative of u with respect to v is equal to what? Let's simplify the numerator. We have 1 plus e to the negative v times negative e to the v. Alright? Minus 4 minus e to the v times what? Negative e to the negative v. Over 1 plus e to the negative v squared. Now, if we simplify, do we have a common factor? There's none, because we have e to the v here, but the other one is e to the negative v. So what we do is we distribute and then collect similar terms. So we'll have to multiply these two. Alright, so we have in the numerator, we have negative e to the v, 1 times negative e to the v, minus, plus minus. So e to the what? What's e? So note that when we multiply e to the negative v by e to the v, what does it give you? We add the exponent, so this is e to the what? V minus v, which is 0, and e to the 0 is 1. Alright? I think I have to write it down here. Wag na dito. Okay, but it's good to write it also on that side. So, e to the next is what? Minus e to the negative v times e to the v. Okay, again, 1 times negative e to the v is negative e to the v. Then we multiply e to the negative v by e to the v. Then, minus. Okay, we multiply this two. So, distribute it here. So, we get what? Negative 4. Because negative times positive. So, negative 4. Hold on. Naiba yung color. We have negative 4 e to the negative v. Then, minus of plus e to the v times e to the negative v over 1 plus e to the negative v squared. So, if we simplify, hold on, pangit. If we simplify, we'll get what? Again, as I mentioned, if you multiply these two, it gives you e to the minus v plus v. Minus, distribute the negative sign. So, hold on. If you distribute this becomes positive 4 e to the negative v minus e to the v minus v. Okay, we distribute the negative sign. So, this is also negative. E to the v minus v, right? Over 1 plus e to the negative v square. And if you simplify this further, again, what is e to the v times e to the negative v times v? Let's write it down here. It's e to the minus v plus v, which gives you e to the 0, which is 1. So, therefore, this is equal to, let's use a different color for this. This is equal to what? Kasi you'll have e to the v, negative e to the v, minus 1. Because it's e to the 0. And then, plus 4 e to the negative v. And again, this is what? 1. This is also 1. E to the v minus v. So that is also minus 1 over 1. Hold on. Minus 1 over 1 plus e to the negative v squared. And if you simplify, we say that these two are similar terms. No, they are not. Because 1, the product of the first, the exponent of the first e, the exponent of the first e is positive. But, hold on. We have to remove the yellow. Okay. Okay. So, this gives you e to the negative v, or negative e to the v plus 4e to the negative v minus 2 over 1 plus e to the negative v squared. Could not simplify it anymore. Okay? So, that's number 4. Okay? Now, let's number 5. For 5, we still have a space. Yes. Okay, for number 5, we're given f of t. Let's change that to x. Let's try writing f of x is equal to 1 plus 5x over 5 to the x. Alright? Okay. So, what formula will you use here first? What will you apply first? We apply first, which one? Derivative of quotient, u over v. So, this is u, and this is v. Alright. So, we have here what? For u over v? V du minus u dv over v square. Right. So, what is our f prime of x? You'll have, copy v. What is our v? 5 to the x. Derivative of the numerator is what? 5. Minus 1, copy the numerator. 1 plus 5x. U dv. This is your u. So, what is dv? What's the derivative of v? We have derivative of 5 to the x. A to the u. So, 5 to the x ln of 5 times 1 over 5 to the x squared. So, if we simplify this, do we have a common factor in the numerator? Check for common factor. What's common? 5 to the x is common, right? How about 5? It's not, because you have on the right side, on the next term, you have ln of 5. So, 5 is left minus, is 5 common? It's not. Kasi 5 is in the first term, but there's no 5 in the second term. Okay. So, it's not common. So, what do we do? So, we have, is 5 to the x times 5 25 to the x? No. So, they are different. So, we have 5 to the x times 5 minus this. Sorry. We need to what? Distribute this one, this here, to 1, and write the negative. So, it's negative 5. It's negative 5 to the x ln of 5, negative, and then minus 5x times 5 to the x ln of 5 divided by 5 to the x squared. So is 5 to the x common? Now 5 to the x is common. Let's revise. Kasi common yung 5 to the x eh. Let's, sorry. Because later I see that it's common. Hold on. So I told you there are times when we could not see which one is common. But later on, you'll see that you'll see the common factor. So 5 to the x is here. Right? You can see 5 to the x here. And there's also 5 to the x here. So we say that 5 to the x is common. Alright, let's remove this. Okay, so we first factor out 5 to the x. And so here, what's left is 5 minus what? 1 plus 5x times ln of 5. Because 5 to the x is out already. Divided by 5 to the x squared. So therefore, here, we can cancel 1 of 5 to the x. So in the numerator, we'll have 5 minus, distribute ln of 5. Because you have here, you can distribute this here. So we'll have minus ln of 5 minus 5x ln of 5. So we distribute ln of 5 to 1 plus 5x. So ln of x, it should be plus 5x ln of 5. But you distribute this negative sign. And then we have 5 to the x. Because the other 5 to the x is cancelled in the numerator. Alright, so we could not group any similar terms in the numerator. So this is the derivative. Okay, so do we have other numbers? Wala na. Okay, so the next that we have is the derivative of, hold on, are we done with this? Yeah, we're done with the last number. 1 plus 5x. Okay, so the next is, we're done with the derivative of exponential. Now we have the derivative of logarithmic function. So what this meant by, so we learned this in algebra, that when we say logarithmic, it's the inverse of exponential. So y is equal to the log of x to the base a is the logarithmic form. And it's true if x equals a to the y. This is the exponential form. Alright? Then these are the graphs of those of the logarithmic function. And this is the definition. Alright, let's go over this one. A logarithmic function with a base a where a is greater than 0 and a not equal to 0 is defined by this one. So, y, ito yung sinabi dito kanina. Y is the log of x to the base a if and only if x is a to the y. So y is the log of x to the base a is in the logarithmic form, and x is a to the y is in the exponential form. So we have these examples here. So we could write the log of 4 to the base 16 is 1/2 into this form. So this is in the logarithmic, this is in the exponential form. So if it's written this way, the base is 16. So 16 raised to the 1/2 is 4. And you know that the square root of 16 is 4. Now the next one has a base which is 2. So 2 raised to the third is a. And we know that 2 cubed is 8. Alright, so this is how we change from logarithmic to exponential and vice versa. We use these two. Okay, now we have here the derivative of logarithmic function. Now, again, we discussed in algebra that we have two kinds, or we have different kinds of logarithm. It could be any base a, but when it comes to base e, which is equal to 2.71, if the base is e, we call it as natural logarithm. So, you have here a natural logarithm, log of x to the base e. But instead of writing it this way, we could just simply write it as ln of x. So when you see ln of x, it means you have natural logarithm. Now the other one is common logarithm. So if the base is 10, you have the log of x to the base 10. But sometimes the base is not indicated. If it's not indicated, it's understood that you have common logarithm. And then you have to go over the laws of logarithm. We discussed that also last time, right? Okay, so these are the different formulas. First is, what is the derivative of the log of u to the base a? It's 1 over u log of e to the base a du dx, where u is a function of x. Now, it says that if the base is a, we could also write it as 1 over u ln of a du dx. But we just simply use this one. You may not use this anymore. So, the derivative of log of u to the base a is 1 over u log of e to the base a du dx, where u is a function of x. Now, if you have the base e, you know that if the base e, it's natural logarithm. So, instead of log of e to the base u, you could just simply write it as ln of u. And from here, because this will give you 1, then it's simplified into 1 over u du dx, where u is a function of x. So, let's write it down here. What's the derivative? Let's use a different color. What's the derivative of the log of u to the base a? It's 1 over u log of e to the base a du dx. What's the derivative of ln of u? 1 over u du dx. Alright? Okay, so let's have examples here. Okay, so how do we find the derivative of ln of 5x squared? Now, you can have this be your what? Actually, there will be two solutions for the first number. Hold on. If by the laws of logarithm, could we bring down x cubed? Yes, pwede. Pero let's use here first the formula that we have the derivative of what? Ln, okay, hold on. The derivative of ln of u is equal to 1 over u du dx. So here, this is u. So what is the derivative? 1 over u, 1 over 5x cubed times what? The derivative of 5x cubed, which is 15x squared. Alright, so we can cancel out 15 and 15. Sorry, 15 and 5. So we have here 3 in the numerator, and then this cancels out. You have x. So f prime of x is equal to 3 over x. 15 over 3 is 3. Yeah. Now, look at this one. Can we simplify f of x is the ln of 5 to the x cubed into this form? Can we write it as x cubed ln of 5? Yes, we could. So, if given f of x is x cubed ln of 5, what's the derivative? You'll have what? F prime of x is, this is a constant term, right? So you have ln of 5 times 3x squared. And so this gives you what? 3x squared times ln of 5. And then, hold on. You should get the same answer. Ln of 5 to the x cubed. Yeah. It should be 1 over u. This should be 3x, 3 over x. Hold on. We should get here also 3 over x. ln of 5. Kasi we could write this as, we could bring this up. Yeah. But we have to simplify. Hold on. Wag na lang to. because you should get the same answer, but we still have to simplify this. So, medyo mas mahaba yung solution. Alright? So, we don't simplify yet. So, again, what's the derivative of ln of u? You have 1 over u du dx. Your u is 5x cubed. So, 1 over 5x cubed times the derivative of 5x cubed, which is, sorry, that's why we get a different answer, because I made a mistake. What's my mistake here? Mali ito. Right? So, what should this be? Let's do it again. And sometimes you really can commit mistakes. But okay. So, what is f prime of x? So, 1 over u, 1 over 5 to the x cubed. Kasi I write it down as 5x cubed. It's 5 to the x cubed. Times what? 1 over u, derivative of u. What's the derivative of 5 to the x cubed? So, we use here what? Derivative of a to the u. It's a to the u ln of a du dx. Right? So, what is your a here? Wait, hold on. Let's write down muna. Okay. Again, what is our f prime of x? We have 1 over u, which is 5 to the x cubed, times the derivative of u. So, to solve for the derivative of u, we use what? Hold on, babangga siya dito sa formula ng kabila. So, we use which one? Let's use again the derivative of what? Derivative of a to the u, which is a to the u ln of a du dx. So, here, this is a, and this is u. Alright, so, what's the derivative therefore? A to the u, so 5 to the x cubed times ln of 5 times the derivative of u, which is 3x squared. So, if we simplify, we have what? Can we cancel 5 to the x cubed? Yes, we can. So, this cancels out with this one. So, what's left is 3x squared ln of 5. That's your f prime of x. Alright? Now, as I've mentioned, we could write it this way kasi we are given or. What is given is f of x. Let's use a different color. We're given f of x is what? Ln of 5 to the x cubed. So, by the laws of logarithm, we could bring this down. So, you'll have x cubed ln of 5. And then, to find the derivative here, we use product. So, we copy x cubed. Derivative of ln of 5 is 0 because ln of 5 is constant. Plus ln of 5 times the derivative of x cubed, which is 3x squared. And so we get 3x squared ln of 5. So we get the same answer. Alright? Kasi kanina magkaiba yung 5x cubed yung naisulat ko sa baba. Anyway, let's do number 2. So for number 2, what is number 2? Y prime is equal to what? So again, we have here what? We have here, you have a constant times this one. So we copy the constant term, and then we multiply it by the derivative of ln of x to the 5th times x cubed. But look at this one. You have here the derivative of the product. So it's easier if you're going to simplify this first. Because we can simplify this so that this is the same as what? 2 times ln of u times v. Sorry. Malikot itong ano. So, we could write this as ln of e to the 5th plus ln of x cubed. Alright? So, it's easier. Why is it that we first simplify? Because when we simplify, differentiation is easier. Look at this one. Because I first simplify ln of 5 to the x cubed using the laws of logarithm, differentiation is just 2 steps. So, same thing happens here. we could write this as ln of e to the fifth times x cubed can be written as ln of e to the fifth plus ln of x cubed. And we can simplify this further so that you'll have 2 times ln of e to the 5. Pwede rin tong 5 ln of e. Pero still, because this will give you what? The same derivative because this is already constant. But we can also write it as 5 ln of e. Then plus, you could have plus, bring this down, so you have 3 ln of x. So this is now your y. And y prime now is, we copy the constant term, then multiply it by the derivative of this term. And as I mentioned, this is constant. So the derivative of that constant is 0. Plus 3, derivative of ln of x is 1 over x times 1. Derivative of ln of u is 1 over u du dx. So if you simplify, this gives you 2 times what? 3 over x, or simply, that's 6 over x. Okay? Now, what's the next one? The next problem is, hold on. Nawala. Okay. The next one, I have a space here. To here. What's the derivative of the log of z squared minus 4? So what formula will you use here? You have the derivative of what? The log of u to the base a is 1 over u log of e to the base a du dx. So here, this is u. So what's the derivative? You have 1 over u, which is z squared minus 4, times the log of e to the base 4, because the base here is 4, times the derivative of u. Your u is z squared minus 4, so it's 2z. Alright? So if you simplify, this gives you 2z times the log of e to the base 4 over z squared minus 4. Mabilis lang yung derivative. Alright? So we use here the log of u to the base a. Number 4. For this one, we first could simplify this kasi, look, you have v is ln of x squared plus 4x over 2x minus 3 cubed. So look, this actually, we can find the derivative of v with respect to x, right? We could write it that way. Now, before you differentiate, you simplify this first using the laws of logarithm, because this can be written in this manner. Minus the ln of 2x minus 3 raised to the third. Okay? Because you have quotient, it comes from difference. Hold on a second. Okay, so, and then we can still simplify further. Kasi ito, we can bring this down here. So we'll have here ln of x squared minus 4x minus 3 ln of 2x minus 3. Look, this is now your new function. Your v. So we were able to simplify this into what? Okay, let's just write it down. So we were able to write down v is equal to ln of x squared minus 4x minus 3 ln of 2x minus 3. Now look, it's easier to differentiate this one rather than this one, because here you'll be using quotient. Dito wala nang quotient. For the next one, you simplify, there's no quotient anymore. So it's easier to find the derivative of v with respect to x. So we use here the derivative of what? What formula will you use here? We use the derivative of ln of u is equal to what? Okay, let's just write derivative of ln of u is 1 over u du dx. So here, this is u. So the derivative is 1 over x squared minus 4x times the derivative of x squared minus 4x, which is 2x minus 4. Then minus, you have the constant here, copy the constant, times the derivative of ln of u. So 1 over u, 2x minus 3 times 2. And then we simplify. So here we have 2x minus 4. So we'll have here, what happened? You have 2x minus 4 over x squared minus 4x minus 2 times 3 is 6 over 2x minus 3. And then you need to what? Get the LCD. So find the LCD here and simplify, and this is the final answer. So continue this one here. Continue simplifying. Find the least common. So look, your least common here is x squared. Hold on, this must be plus. X squared plus. This is plus. So this is 2x plus 4, 2x plus 4. Alright, kasi it's plus here. I put negative. So 1 over x squared plus 4x times 2x plus 4 minus 3. Okay. So do this at home and continue solving for the simplified form to get this one. To get the pink answer. dv dx. Okay. Let's do the next one. So what is r of t? Again, we can first simplify this. Now just use here parentheses. Okay, hold on. We have a parenthesis here, not an absolute value. Okay. So, you have here ln of t cubed minus 4 times 4t plus 7 cubed. So, this can be written as what? Kasi we have here, let's just simply rewrite this. Medyo magulo. Okay, hold on. This is r of t is ln of t cubed minus 4 times 4t plus 7 cubed. Ganun dapat siya. Alright? So, r of t, so hindi na to yung problem ha. Ito na. So, we write r of t is equal to what? By the laws of logarithm, kasi you have, mali yung ano ko. Hold on a second ha. Mali ito. Dapat, nandito siya. ln of the 2. So, here, you have the ln of the product. Diba? From our laws of logarithm, if you have ln of x times y, it's ln of x plus ln of y. That's what we did here. Here, you have the ln of the quotient. So, you have difference. Now, if it's product, it's the ln of the sum. So, this can be written as ln of t cubed minus 4 plus ln of 4t plus 7 raised to the third. So, your r of t is equal to, we can still simplify and bring this down here to make the solution easier. So, t cubed minus 4 plus 3 times ln of 4t plus 7. So, this is now our function. So, we're able to simplify it first before we differentiate for us to make differentiation easier. So, now, what is our r prime of t? So, ln of u. This is u. Hold on. This is u. Hold on a second. This is your u. Here, this is your u. So, what's the derivative of ln of u? 1 over u t cubed minus 4 times the derivative of u. Plus, here you have constant, which is 3, times the derivative of ln of u. So, 1 over 4t plus 7 times 4. Alright? And then to simplify again, check if there is a common factor. So, what's common? Is 3 common? Yes, you have 3 here, and you also have 3 here. So since 3 is common, we factor it out. So what's left inside? You have t squared over t cubed minus 4. Alright, then plus 4 over 4t plus 7. Again, you continue simplifying by getting the LCD and group similar terms. So you continue this one. Alright. Okay, and we have here some exercises for you to solve. Now, the next part is about derivative of trigonometric function. So I discussed with you already some of the formulas. So I'll just continue. This is for our Wednesday class. So I'll continue with the derivative of logarithm, with these examples. Try this first. Try first 1, 2, and 6. And I'll solve this in my next video, in my next screen recording. Okay?